All right, this is for chapter 7.4 for complete, concise, and consistent representations. Okay, so the focus of this section is mainly on tree diagrams. And if you recall, as discussed in class, we use tree diagrams to represent more complex situations. An example would be, let's say, if your total were to be changing, you would not ideally use a Venn diagram in that case, or else you would have to keep creating a new Venn diagram every time your total changed. So to take into account those changes, a tree diagram would be the more appropriate tool to use to show the chances of, let's say, getting one certain event over the other. Okay, so according to your book's definition, a tree diagram is another way to represent all the possible outcomes of an event, and the end of each branch represents a combined event. Okay, so I'll go and consider example 15 right away. Okay, in example 15, we're told that you have batteries of different colors. Okay, and then there are 5 red, 6 blue, 7 orange. 2 batteries are chosen, and then find the probability that both are different colors. So step number 1 in a problem like this is you need to identify what are the different possibilities. And in this case, we have three different possibilities. We have the red battery, the blue battery, and the orange battery. Okay. The next thing we need to do is figure out what's the total. Okay, and if you read the question, we have 5 red, 6 blue, 7 orange. If you add all of those, you should get 18. So that's what I'll put here. Okay, the denominator for all of the colors would be 18 because that's the total number of possibilities you're beginning with. Okay, now out of the 18, how many are red? According to the problem, we are told that there's 5 red batteries. And then we also have 6 blue batteries. And we also have 7 orange batteries. Okay, so that's the first part of the tree diagram. Notice that there is a common point. Okay, and then there are 3 branches sticking out representing the different possibilities from this first selection. Okay, now if you look at the image or the explanation in your book, notice that each color will branch out another time. So the question is, how do I know if I'm supposed to continue branching out? Well, that depends on the number of trials, you might say, or the number of times you're doing this. So for example, in this case, it's telling us that you're selecting or you're choosing 2 batteries. So for this diagram, this is only showing me one selection so far. Either I get a red, a blue, or an orange. Okay, but if I were to do this again for the second time, each one has its corresponding probabilities. So for the red, let's say for example, I did get a red for my first trial. So I'll have to do that again, select a different one. Okay, that will have its corresponding probabilities. If ever I selected a blue, that one will have its own corresponding branches afterwards. And then if I did get an orange, similarly, that would have to branch out 3 times, okay, with the same colors involved. So I'm just labeling it, okay, and my tree diagram does not look neat, okay? So just make sure for the first branch, it's kind of spread out evenly so you don't have this kind of issue later on, okay? So notice that for this problem, this is without replacement, meaning if I get one battery the first time, I'm not going to replace it with another one. And so what that means is my total the second time around should change and decrease by 1, okay? Because again, I've already selected 1 out of 18. So it only makes sense to say that if there are 17 left. Okay, so let's see if I can read my diagram. Okay. Now, let's focus on the red part. If I got a red the first time, okay, how many reds will be left? Well, that means if I were to get a red again, I would only be left with 4. Okay. But what if, and in that case, if I got a red the second time, that means the number of blues and oranges shouldn't change. And so I would still have 6 blues and 7 oranges. Okay. Now, what if I got the blue the first time? Okay, if I got a blue the first time, that means my number of reds shouldn't change. Okay, and if I were to get a blue again, then that would have to decrease by 1. So coming from 6, I now have 5. Okay, and then that also means that my oranges shouldn't change because I've never selected an orange yet at this point. And then I'll do the same thing for this third branch here. If I got an orange the first time, that means my reds wouldn't change. I would still have the same number of reds. I would also still have the same number of blues, but my orange here will decrease by 1. That means I'll only have 6 oranges left. Now, for a neater diagram, just refer to your textbook. Okay, again, this is just me explaining how the numbers appeared, or the probabilities, I should say. Okay, so now going to the question, we're asked to find the probability that both the batteries are different colors. So we're going to compare all of the possible combinations wherein I got a different color the first and the second time. Okay, so to do that, I'll start with the first one. So let's say I got a red the first time around, and that means the probability of getting a red first time is 5/18. Okay, and then I cannot get a red again because the question wants me to get a different color. So that means if I got a red here, it's either I get a blue the second time or an orange the second time. So I'm going to combine those probabilities. So 5/18, and then I'll multiply that to that second segment, and that should be 6/17. Okay. And then the other possibility, so I'll be adding that other possibility, is I get a blue the first time around. So that's 5/18. I'm still looking at the red. But instead of getting a blue, I get an orange. So that's times 7/17. Okay. And then moving on, I could get a blue the first time around, so that will be 6/18. Multiply that by a red because those are different colors, so that would be 5/17. Okay, another possibility is again I get blue the first time, but I get orange afterwards, so that would be what, 7/17. Okay, and then I could get an orange also, my first try, and then get a red afterwards. So that would be, what's red? Oh, I can't, 5/17. Okay, or I could get an orange and then a red, which is a 6/17. Okay, and then you would just plug this in your calculator and you should get the same answer as what's in your book. Okay, so now notice how I put parentheses or brackets. Okay, I would encourage you to do that. Your book does not show that, but it would be better if you do, so you can clearly see what were the groupings that you formed. Okay, another thing that I forgot to mention at the start of this video is how do I know whether I'm adding or subtracting, or sorry, adding or multiplying. I will add my probabilities if I'm going from one segment to the next. Okay, so for example here, sorry, let me repeat that. I will be adding my probabilities if, let's say, I'm looking at 5/18 and 7/18, because they're from a common point or vertex or root, whatever you want to call it, and you're combining them, you'll be adding them. Okay? But if you're going from left to right, if you're going from one segment to the next, from one vertex to another vertex, the relationship is you multiply them. And that's the reason why here, if you notice, I multiplied 5 over 18 and 6 over 17. Because they're coming, right? You're going from one vertex to another, one segment to another, okay, one trial to another, whatever you want to call it, and hence you multiply it. But when I compared, or when I combined that with the other possibility, I have to add it because, again, I'm combining possibilities here. Okay, what is the overall total possibility that I get a different color from both trials? All right, so that's how one way to do it. Another way you could do it, and the book explains this, is you could just get 1 minus the complement. So if the question is asking you to find the probability that both the batteries are different, what you can do is find the probability that they're the same. So that would be 5 over 18 times 4 over 17, or 6 over 18 times 5 over 17. Basically, the ones wherein you get the same color on both tries, you would multiply and add accordingly and then subtract 1 from that. Okay, so again, your book gives you a more detailed explanation. I will not get into that because it's basically the same thing. But this is how you would construct and understand a tree diagram.